Welcome, everyone. Today, we are diving into two foundational pillars of cloud computing, reliability and predictability. Let's get started. Welcome to our training. Today, we are exploring two incredible benefits of cloud computing, reliability and predictability. Think of reliability as your system's resilience. It is the ability of your system to automatically recover from failures and continue to function without your users even noticing a hiccup. Predictability, on the other hand, lets you move forward with absolute confidence. It means you know exactly how your applications will perform under stress and exactly what it will cost you. Together, these two pillars transform your IT from a reactive cost center into a proactive engine for innovation. Take a look at this diagram. At the top, we have our core cloud benefits. This splits into our two main focus areas for today's session. On the left, reliability directly leads to the ability to recover from system failures seamlessly. On the right, predictability branches into two distinct and vital categories, performance and cost. As we move through this training, we will dive deep into each of these notes, unpacking exactly how the cloud delivers on these specific promises step by step. Let's dive into reliability. Why is the cloud inherently reliable? It all comes down to its foundational architecture. The cloud, by virtue of its decentralized design, naturally supports a highly reliable and resilient infrastructure. Instead of putting all your eggs in one basket like a single on-premises data center building, you leverage global scale. You have the ability to deploy resources in regions all around the world. This means if a hardware failure occurs in one specific location, your system isn't doomed. The decentralized nature of the cloud absorbs the impact, keeping your critical services online. Here we see a visual representation of this decentralized design. User traffic flows into the overarching cloud infrastructure. Instead of routing to a single vulnerable point, the traffic is directed to Region 1, which is currently active. But notice Region 2 right below it, connected by a dotted line. Because resources are deployed globally, Region 2 is ready and waiting. This geographic distribution is the key to minimizing risk and ensuring your application remains highly available regardless of local disruptions. Now, let's take a deeper dive into extreme scenarios. What happens during a major disaster with global scale? Even if one entire region experiences a catastrophic event, other regions are still up and running. As an architect or developer, you can design your applications to automatically take advantage of this increased reliability. And the absolute best part, in some cases, your cloud environment itself will automatically shift traffic to a different, healthy region for you, with no manual action needed on your part. You don't have to wake up at 3 a.m. to flip a switch. The cloud handles the recovery. Let's walk through the sequence diagram to see automatic failover in action. A user sends a request to Region A. Suddenly, a catastrophic event takes Region A offline. The initial request fails. However, the cloud platform detects this and executes an auto-shift. The very next user request is seamlessly routed to the healthy Region B, which returns a success message. This beautifully illustrates how the cloud environment itself can automatically shift to a different region, ensuring continuous operation without you lifting a finger. Transitioning from reliability, we arrive at our second pillar, predictability. Predictability in the cloud lets you move forward with absolute confidence. But what does that mean practically? It means we can accurately forecast two critical business metrics, performance and cost. Whether you are launching a new product or scaling an existing one, you shouldn't be guessing how your system will behave or what your invoice will look like. Both of these predictability types are heavily influenced by the Microsoft Azure well-architected framework, which provides the golden standards and best practices to achieve this stable state. This flowchart illustrates the foundational role of the Microsoft Azure well-architected framework. You can see it sits securely at the top, directly influencing both performance predictability and cost predictability. Following this framework ensures that performance predictability leads to a positive customer experience, while cost predictability leads to financial confidence. By deploying a solution built around this framework, you guarantee that both the cost and the performance of your system are highly predictable. Let's examine performance predictability closely. This is entirely focused on predicting the resources needed to deliver a consistently positive experience for your customers. We achieve this through core cloud concepts, auto-scaling, and load balancing. Imagine a sudden, massive traffic spike. Auto-scaling instantly deploys additional resources to meet that demand, and just as importantly, it scales those resources back down when the demand drops. Furthermore, if traffic overwhelms one specific area of your app, load balancing steps in to redirect that overload to less stressed areas, ensuring smooth, predictable performance. This diagram brings performance predictability to life. Heavy user traffic enters the system and hits the load balancer first. The load balancer's job is to prevent overload by redirecting the traffic efficiently. It smoothly distributes the incoming requests to VM1 and VM2. But look at the dotted line to VM3. Because the load was too high, auto-scaling automatically deployed an additional resource VM3 to meet the sudden demand. Your customers never experience lag, and you didn't have to manually rack a new server. Our next stop is cost predictability, which is focused strictly on predicting or forecasting the cost of your cloud spend. The cloud gives you the incredible power to track your resource use in real time and monitor those resources to ensure you are using them in the most efficient way possible. Beyond just tracking, you can apply data analytics to your usage data. This helps you find patterns and trends that allow you to better plan future resource deployments. And before you even build anything, tools like the total cost of ownership or the pricing calculator give you highly accurate estimates of your potential cloud spend. Here we see the life cycle of cost predictability. At the top left, before deployment, you use the pricing calculator to forecast your costs. Once deployed, the bottom workflow takes over. You start with real-time tracking of your resources, which feeds directly into data analytics. The analytics engine helps you find patterns in your daily spending. Finally, based on those patterns, you can dynamically adjust your resources as needed to maintain your budget. It is a continuous loop of financial optimization. Let's apply this to a real-time use case, a global e-commerce platform hosting a massive flash sale. This scenario demands both reliability and predictability to succeed. First, reliability. Imagine a thermal event takes a data center offline mid-sale. Because of the cloud's decentralized design, traffic automatically shifts to another region and shoppers keep buying. Next, performance predictability. As thousands of users log on simultaneously, auto-scaling instantly deploys additional resources to handle the surge, guaranteeing a seamless checkout experience. Finally, cost predictability. The finance team uses real-time tracking to monitor the cost of these extra servers, knowing costs will shrink the moment auto-scaling removes them after the sale. This diagram models our e-commerce flash sale scenario. The shoppers hit a global load balancer. It directs them to Region 1, where auto-scaling is actively managing the traffic spike, ensuring total performance predictability. Notice the connection to real-time cost tracking. This represents cost predictability, monitoring the exact financial impact of the sale. And if Region 1 experiences a critical failure, the dashed line to Region 2 shows our reliability in action. Traffic instantly fails over to a secondary region to keep the platform online and generating revenue. To wrap up, reliability and predictability are not just technical features, they are critical business enablers. To master them, follow these best practices. First, always design for failure. Leverage the cloud's decentralized design so that even catastrophic events don't take you offline. Second, utilize auto-scaling and load balancing to ensure your performance remains perfectly predictable during demand spikes. Finally, never stop monitoring. By operating in the cloud and using data analytics, you can continuously predict future costs and dynamically adjust your resources as needed to stay on budget. Thank you for joining this deep dive into cloud excellence. Our final diagram brings the entire concept of cloud excellence together. True excellence relies equally on reliability and predictability. Reliability is driven by global scale and automatic failover mechanisms, while predictability is anchored by the principles of the well-architected framework. As the arrows converge at the bottom, we see the ultimate goal: business innovation. By mastering these two pillars, your cloud infrastructure becomes a powerful, invisible engine for reliable, cost-effective, and high-performing business growth.